Good morning, students. So today we are going to start with the new topic, that is the fourth unit from your engineering mathematics 2, data and gamma function. First I will continue with the gamma functions, its properties, numericals on gamma function, and then I will switch to the beta. So again, very first I will tell the instructions. When I ask the questions, I will take the name. You have to unmute and respond immediately. Okay. Now first I will start with the definition of gamma function. So for definition, so I will write a particular integral. Suppose an integral which is given by the limits of the integral is 0 to infinity. The limits of the integral is 0 to infinity. Integrand is e raised to minus x into x raised to n minus 1 dx. Okay. Suppose I am defining this integral. Limits of this integral from 0 to infinity, and the integrand is e raised to minus x into x raised to n minus 1. So finally, when you evaluate this integral, it defines a function. It defines a function of some particular variable. Okay, for examples, for your understanding, I will write. Suppose integral 1 to 2 x raised to a dx, means what you are doing, you are taking integration of x raised to a as x raised to a plus 1 divided by a plus 1, and finally you are substituting the lower limit for x and upper limit for x. And if you substitute the upper and lower limit, the actual process that you have to replace that x by 2, you will get 2 raised to a plus 1 divided by a plus 1 minus 1 raised to a plus 1 divided by a plus 1. So any 1 raised to anything that becomes 1. Further, you may simplify this as divided by a plus 1. That term is there, and the numerator is 2 raised to a plus 1 and minus 1. So this is the evaluation of the integral. Means this integral defines a function of some independent variable. So in this case, suppose this is a function and I will denote this f. Then this is a function of which variable? That is my question. Aditya, suppose this integral 1 to 2 x raised to a dx, it defines a function, and that function I am denoting as a f. Then this f is a function of which variable? What is the independent variable? Yes, Aditya. Yeah, it is a function of a, because what happens up to the end when you are taking the evaluation of the integral, so you are substituting x is equal to upper limit, x is equal to lower limit, and their subtraction. So it defines a function of a variable. This integral defines a function of variable a. So in the same manner, my next question is, suppose this is an integral where limits are given 0 to infinity. Integrand is e raised to minus x into x raised to n minus 1 dx. So again, this integral defines some function. This integral defines some function of the independent variable. So what is the independent variable for this integral? Yes, Kavita. Yes, Yogesh says that n. So ultimately the value of the integral defines or depend on the value n. So this integral defines a function of n, and that function is called as a gamma function. So that function is called as a gamma function. So it is denoted as the function in notation. In the function notation, I will write the function. This is a notation to denote the gamma function. So here the value of n, we are taking only a set of positive real numbers r plus, and their evaluation is any r plus to r, defined by the rule. So how it is defined? It defines a function of, and gamma function is denoted by one straight line, one horizontal line. So gamma n is equal to, and suppose this integral I will denote as a number 1, this integral I will denote as a 1, is called gamma function, is called gamma function. So if you look at the nature of integral, so these are the improper integrals, and easily it is not possible to evaluate the integral. In some cases it may becomes difficult to evaluate. So that's why we take help of gamma functions to evaluate this integral. We take help of gamma functions to evaluate this integral. Now few observations. One thing you can notice that integral involving the integrand involving two terms. One is e raised to minus x, and the another one is x raised to n minus 1. And remember, whenever you are reducing a particular improper integral or integration to gamma form, or in the gamma definition, gamma form, so in that case our focus should be to obtain the term e raised to minus x. X is the parameter, e raised to minus x, and this is called as kernel of the integral, kernel of the integral. So our focus should be to obtain e raised to minus x, or x is not a definite integral, is independent of parameter. You may use any other parameter also. So this e raised to minus x is called as a kernel of the integral. So our focus should be to obtain limits 0 to infinity and e raised to minus x as the term. So here r plus, what it r plus denotes, this one, what it denotes, set of positive real number. So r plus denotes set of positive real number, and r is nothing but its evaluation may be any real number. The integral defined one exists, or we can say converges, if n is greater than 0. So you can take a note of this. What is the note? So this integral not convergent always. So for the negative value of integer n is equal to minus 1, minus 2, like that. So this integral is not convergent, but the negative value evaluate. But for our study we take n is positive. The integral defined by 1. The integral defined by 1 exist, or we can say convergent. Convergent means the integral exists, converges if this n is greater than 0, sorry, n is greater than 1. Remember this part, n is, sorry, greater than 0, not 1. So n is greater than 0. We can take 1 also, n is greater than 0. Now next we will see some properties. So properties of the gamma function. Okay, actually that groups are not expected to explain, but still I will explain properties of the gamma function. So first property, now I will give 1 or 2 minutes. Can you try? What is a gamma 1? What is a gamma 1? First property, gamma 1 is equal to, now the question mark is there. Can you evaluate? Suppose these are very simple. By definition of gamma function, by definition of gamma function, gamma 1 is nothing but, or gamma n is equal to limits from 0 to infinity e raised to minus x, x raised to n minus 1 dx. So in this result, or in this definition, you have to put n is equal to 1. That's why. So gamma 1 is equal to integral 0 to infinity e raised to minus x, x raised to 1 minus 1 0 dx. Yes, Guru, can you tell what is the value of x raised to 0? Yes, anything raised to 0 is 1, so not necessary to write this term. So this can be written as dx. Now what is the integration of e raised to minus x? Shruti, integration of e raised to minus x, integration of e raised to minus x. Very good. It is e raised to minus x upon minus 1. Now this is a definite integral. So at the end, you have to substitute x is equal to upper limit and lower limit. So when you substitute x is equal to upper limit, it becomes e to the power minus infinity divided by minus 1 minus lower limit is e to the power 0 divided by minus 1. Now, what is the value of e to the power minus infinity? Rida? What is the value of e to the power minus infinity? As a standard result, you have to remember. Rida? Don't know. Okay. Shruti? What is the value of e to the power minus infinity? Okay, Shivani, you want to tell? Shivani? Tends to 0 means we approximate it as 0. See why? E to the power minus infinity is nothing but 1 upon e to the power infinity, and e to the power infinity, again infinity is a very big number, e to the power infinity is also very big number, and it tends to 0 or it can be approximated as a 0. Okay, so henceforth as a standard result, most of the time we will get this value as a standard result. Remember e to the power minus infinity as a 0. Okay, that means evaluation of the term at upper limit is 0 because e to the power minus infinity is 0. Lower limit minus and minus and anything e to the power 0 is e to the power 0 is 1. Okay, so that's why as a first property you can remember, so gamma 1 is equal to 1. So while solving the example, if you are getting gamma 1, so directly you replace that value as 1. Okay, now the second property is gamma n plus 1. This is also called as a reduction formula. So second property is gamma of n plus 1 is equal to n gamma n if n is greater than 0. It may be real, it may be integer. Okay, so by definition I will continue again. Okay, by definition, so by definition of gamma function, by definition of the gamma function, gamma n plus 1 is given as integral 0 to infinity e raised to minus x raised to n plus 1 minus 1. Am I right? Because the definition of gamma n is given by integral 0 to infinity e raised to minus x raised to n minus 1 dx. Now in this case you are evaluating gamma, so that's why the power is that n minus 1. Now in this case we are evaluating n plus 1, so n plus 1 minus 1, that value. Okay, now further it can be simplified as integral 0 to infinity e raised to minus x raised to n dx. And suppose I have to evaluate this integral. So what will be your next step? Yes, Sankalp. Sankalp, are we in the class? Yes. Hmm. No. We still not, since you are not using the value of gamma, I have to evaluate this integral by using the product rule. Then what you have to do? That's why I'm writing the word that you may studied in 12th. Correct now? Whatever I written, that is correct. What is it? What is it? Quickly. Yes, light rule you have to you apply. I hope that everyone know the meaning of LIATE. So according to that, what should be your arrangement under the sign of integral for the integrand? What should be your arrangement? Integral 0 to infinity. Suppose you are applying the product rule, means one is u, one is v after rearrangement of the term. So what should be your u? That is my question. X raised to n, that is algebraic, and exponential is at the end. So you have to write x raised to n multiplied by x raised to n multiplied by e raised to minus x dx. Now can anyone help me to write the product rule? Integration of uv with respect to x. U as it is, integration of v with respect to x, am I right? Integration of du by dx. Okay, so in our case, what is our u? What is our u? Here I will write. Okay, so our u is x raised to n, v is e raised to minus x. Suppose you are applying that rule. Now first one, u as it is, that means x raised to n as it is. What is integration of e raised to minus x? This term I am writing directly. What is integration of e raised to minus x? I think just someone told na, Shruti or someone, huh? E raised to minus x, its integral. Good. E raised to minus x upon minus 1. Okay. Now this term I am writing. This term I have completed. This term I have completed. For the second I have to write integral. Minus integral. Minus integral. At the end I will think of the limits. Now the first term is derivative of u. And what is u? Your u is x raised to n. Your u is x raised to n. So its derivative is, yes Atar? U is x raised to n, its derivative. No, I am asking derivative. You are telling integration. It n minus 1. And second term, this one and this term both are same. Already you are evaluated that integral. It is e raised to minus x divided by minus 1, and limit for this integral from 0 to infinity. Okay, limits for the integral from 0 to infinity. Now this question is open to all. Who know the answer, they can unmute and tell. What is the evaluation of the first term? What is the evaluation? I will simplify later on. The first term is x raised to n into e raised to minus x divided by minus 1. So what is the evaluation of that first term? I will highlight if required at upper limit, and upper limit value is infinity. Yes. Yes, very good. Present number is 7 means what in chat box? Okay. So why we are getting 0? Because just we have seen the value of e to the power minus infinity is 0. Okay, value of e to the power minus infinity 0. So when you substitute this value here, see this infinity to here, you will get e to the power minus infinity. That means evaluation of the upper term is 0 minus evaluation of the term at lower limit. Yes, when you substitute x is equal to 0, what will be the evaluation? Sanraj, are you in the class? What is the evaluation of the term at lower limit? I'm using arrows. You should think on that. Are you listening, na? Then what is the problem? Tell me the evaluation of highlighted term at x equal to 0. Someone else who want to tell the answer? Because few names are there. Okay, Shivani, continue. It's 0. It's 0. That means the evaluation of the first term at upper limit, lower limit both becomes 0. Okay, I will rub these arrows. Sanraj, you should be attentive. Huh? I think you are not listening. Okay, the evaluation of the term at upper limit, lower limit becomes 0. There is no question of the first term. Now see the second term, what happens? Now here I am having minus sign. So here I am having minus sign. Again here I am having minus sign. So the term becomes positive, and from that I will take n as outside. Now the remaining integral I will write integral 0 to infinity e raised to minus x. Once again I will rearrange the term into x raised to n minus 1 dx. So what is your opinion, or what is your answer about the remaining integral value? This one. What this represent? What it represent? Gamma n. Very good. Gamma n. By definition, it is nothing but gamma n. You look at this term. So directly by definition, I will replace the value. This one is nothing but n gamma n. That is the property. So thus, the second property says that gamma of n plus 1 is equal to n gamma n. Okay, that is the second property. So further, suppose I will give 1 minute to think on this. If n is specially given as an integer, in that case, what should be the reduction of that property? But I ask, suppose if n is integer, in that case, that is the next property. Suppose the third one, third property, gamma of n plus 1 is equal to, if n is integer. In the earlier case, we are taking that as a positive real number. If suppose that is integer, then what will be the answer? Yes, anyone? No? Yes, Shivan, you want to tell the answer? You can use hand raise option also. I will take directly name. Yes, anyone want to highlight on this? Otherwise, I will explain and try to find the answer. Okay. So I will help you to get the answer. Now by property number 2, gamma of n plus 1 I will write as n gamma n. Okay, n gamma n. So further what I will do, this n I will write as it is. So once again I will apply the same property, that means a property number 2 for gamma n. So what should be the answer? Omkar, question is clear? Okay, so I highlighted gamma n. Okay, so for that highlighted term only you have to apply property 2. Property 2 says that this one, property 2, I think it is visible. Okay, so that property you have to apply, this one. By applying this property, what is the value of gamma n? How it is? So here see, why you are telling answers like this? Anyone want to tell the answer? Okay, once again chance will be given to Sanraj. N gamma n minus 1, Yogesh. Okay, okay. Now think on this. Once again I will highlight. So what you did here, gamma n plus 1, you are writing n into gamma n. But my question is for gamma n. So what you have to do? Prerna? What will be the answer? Don't know. Okay. So yes, very good, Yogesh. So what happened in the earlier case? What you are doing? That number you are reducing by 1, na? Gamma n plus 1 you are writing as a n gamma n, means what you did, that n plus 1 you are reducing by 1. Now in the same manner, that n you have to reduce by 1. If you reduce that n by 1, what will be the answer, Prerna? If you reduce that n by 1, then what will be the answer? 1 न कमी करायचं आहे, बरोबर ना? n minus 1 into gamma of n minus 1. So here what I am going to do, I am going to apply the same rule successively. So once again, gamma n minus 1, can anyone tell? Unmute and tell. So first two brackets I will write as it is. What will be the gamma n minus 1 by using property number 2? Very good. Yes, n minus 2 into gamma n minus 2. So continue this process up to the end. That means I will write the dot n minus 1, n minus 2, n minus 3, continue up to 3, 2, 1 into gamma 1. You have to stop at gamma 1, correct now? So further it can be written as n into n minus 1 into n minus 2 into n minus 3 into, this is a continuous product, 3 into 2 into 1. So what is value of gamma 1 here by property number 1? Shresh, yes, gamma 1 is 1. So here, so this gamma 1 is 1, so that's why that product is up to 1 only. Now anyone want to highlight what is the answer if n is an integer? N is an integer. Very good, very good. It is a n factorial, the definition of factorial. So it is n factorial. Okay, so the property says that if this n is an integer, in that case gamma n plus 1 is given as a n factorial. That is a third property. Okay, I think fourth one. Now fourth property. Now prove the fourth property, we have to wait for the definition of beta. That's why I will give only the property. And while solving the examples, if you are getting this gamma of 1 by 2 and that value directly replace gamma of 1 by 2, and gamma of 1 by 2 is given by root of pi. Okay, gamma of 1 by 2 is root pi. So for time being we accept this result. If required I will write here. For time being, because to prove this result we require beta, and at a beta function I have not defined, we accept this result. Now you can make a summary of 1 page, definition of gamma, then properties of gamma. Now the next one is second definition of gamma function. This also you can refer as a definition of gamma function. Second definition of gamma function. Okay, now we have to suppose prove this. So the second definition of gamma function is given as gamma n is equal to, see what is the difference, gamma n is equal to 2 times integral 0 to infinity e to the power minus x square into x raised to 2n minus 1 dx. So you can refer the second also as a definition of gamma functions. So before proceeding I will write one note here, and I want answer from your end. Okay, note, I will write the integral gamma n. So suppose this one I am writing, gamma of n is given by integral 0 to infinity e raised to minus x into x raised to n minus 1 dx. Now here equal to I am writing, but my question mark is there. Can I write the same integral as integral 0 to infinity e raised to minus y into y raised to n minus 1 dy? So here again a question mark. Can I write the same integral as a 0 to infinity e raised to minus t into t raised to n minus 1 dt? Again the question mark. Can I write this integral as 0 to infinity e raised to some minus p, any parameter, into p raised to n minus 1 dp? Okay, anyone want to comment? Anyone want to comment on this? Tell me whether I should take equal or not, or I have to take the name every time. This question is open to all. Yes, Yogesh says that yes, we can write it because the property of definite integral says that a definite integral is independent of the parameter, whether you write t or y, whatever it. So at the end all the integrals becomes equal. Yes, yes, yes. Okay, so why I am taking this one? Because with the help of this one, either this integral, this we have to prove. Suppose the second integral I want to prove, because or I want to show the integral represented by the definition 1 and definition 2 both are equal. So let gamma n is equal to integral 0 to infinity e raised to minus x raised to n minus 1 dx. Okay, this is the integral, and this integral you have to prove to this form. Now when you are thinking of the gamma function, our focus should be the kernel of the integral. So can you identify the substitution? Can you identify the substitution for x such that we can reduce the given integral to the second definition form? Yes, anyone? Again, definite integrals are independent of the parameter. Yeah. I'm highlighting. Yes. Shivani, you are unmuting. You want to say or you want to tell the answer? Shivani Patil. Okay, no. Omkar, what will be your substitution? Okay, one more step I will write. The same integral, suppose I will write for your understanding 2 times integral 0 to infinity e to the power some minus y square into y raised to 2n minus 1 dy. Because what is the reason? The definite integral is independent of the parameter. Now if you compare the kernel, okay, I required e raised to minus x. Now what should be your substitution? Directly I highlighted that. Yes, Kavita. I am connected, na? Not getting still? Okay. Now here you are having e raised to minus x. And what is required thing? E to the power minus y square. If that term, if you compare exactly, then what is the value of x? I am asking question. Yes. What is the question? Someone should answer. In the chat box I am getting x is equal to y square. I highlighted. I think you like only that I have to teach like yesterday only. No discussion. So what is the substitution, Kavita? Repeat. Y square. Purposefully I have written that integral in the second form. Okay. So to reduce the given integral to this second definition form, your substitution is put x is equal to y square. Means what you are doing? You are converting the variable x to u. If you differentiate both sides, what happen? Differentiation of x is dx, differentiation of y is 2y dy. Now at the same time, limits of the integrations are also changing. So limits for x, limits for y. Now the given limits for x are from 0 to infinity. Okay, 0 to infinity. Now this is your substitution. This is your substitution. Now I am highlighting by yellow color. If x is equal to 0, what is y? Someone should unmute and tell. X is equal to 0, what is y? Is 0. Okay, x is 0, y is also 0. If x is infinity, y is infinity. Again its square root is again infinity, na? X is infinity, y is also infinity. Okay, so these are the new limits. These are the new limits for y. So by using that substitution, I am converting the given integral. I am converting the given integral to y variable. So that's for this gamma n can be written as New limits are also from 0 to infinity. Now e to the power minus y. X you have to replace as a y square and raised to n minus 1. Dx you have to write 2 into y dy. Now from this I will take 2 as a constant outside the integral. 0 to infinity e raised to minus y raised to, using the law of indices, a raised to m raised to n is nothing but a raised to mn, like that. Okay, so this becomes y raised to 2n minus 2 into y dy. And if you take these two terms together, why I'm taking these two terms together? Because their base is same. So their base is same, so you have to add the power. So it can be written as equal to 2 times integral 0 to infinity e raised to minus y raised to 2n minus 2 plus 1 dy, and that we are getting the answer. So again, if you required in the statement form only, it can be written as 2 times 0 to infinity. Definite integrals are independent of the parameter. It can be written as e raised to x raised to n minus 2n minus 1 dx. So this one we consider as the second definition of gamma function, but most of the time we are using the first definition only. Okay, this is the second definition of a gamma function. So which is second definition of gamma function. Okay, I think for gamma function 2 definition and 4 properties are enough. Now I will continue with the examples. So I will not categorize directly. I will take general form and particular form. Suppose first one, examples. Yes, example. Where? Just a minute, just a minute. Something I did mistake here, I think. Yeah. So when I substitute, it is y square. Thank you, thank you. It is e to the power y square. So correct it. Very good. OneNote is not responding. Correct it. It is e to the power minus y square. Now you continue. OneNote is not responding. You correct it. It is a y square. Just a minute. Suppose the first example, integral 0 to infinity e to the power minus a x raised to n dx. So very first step, I will call the given integral as a I. Okay. Suppose for solution, so let I is equal to integral 0 to infinity e to the power minus a x raised to n dx. Now always when you are reducing the improper integral or a particular integral by gamma, our focus should be the kernel. That a particular integral which is reduced to the gamma form, first thing we require limit 0 to infinity, and the second thing e to the power minus parameter. If required, I will paste here the definition of gamma. So this is a definition of gamma for your understanding. Okay, so if you compare with the definition of gamma, what is your substitution? Can anyone guess? This is for your reference. Okay, I am putting here. So what is your substitution? So directly compare here. I think it is not. Yeah, Control Z. Now here, if required, I will highlight a x raised to n and here x. Instead of x, you may think of the new variable. Yes, anyone want to tell what will be the substitution? What will be the substitution? A x raised to n is equal to some another parameter, suppose t or y. Okay, put, what is your substitution? Put a into x raised to n is equal to t, or the same thing can be written as x raised to n is equal to t divided by a, or that same thing can be written as x is equal to t raised to 1 by n and a raised to 1 by n. So what I did here, both side I am taking nth root, both side I am taking nth root, either this or this you may use as a substitution. Okay, now what is the differentiate directly the first one, differentiate. So by differentiating, what you will get, a into n x raised to n minus 1 dx is equal to dt, or from this you can write value of dx is equal to dt upon what will be the remaining term, a n into x raised to n minus 1. Okay, what is the remaining term, a x into this one. Now look, what about the limits? I will write limits in the given form. So for a given limit x, limits are from 0 to infinity. Now you can use the second one or the first one, anyone. Suppose the first, if you are using this one, if x is equal to 0, what is t? Tanmay Patil, suppose if you are substituting x is equal to 0, then what is t? Yes, Tanmaya, sorry, not a. जर x 0 असेल, 0 multiplied by anything 0. If x is infinity, then t is also infinity. Okay, so these are the new limits for t. Therefore the given integral, so I am managing the space only, you can continue with the one by one step. So this integral can be written as integral from, new limits are also from 0 to infinity. So these are the new limits, 0 to infinity, e to the power minus a x raised to n is equal to t, that we have substituted, and dx is given by dt divided by a raised to n, auto mode out of, a raised to n into make me correct if I am wrong, into x raised to n minus 1. Is it right now? Okay, further I have to, okay, I have to replace that x in terms of t, so that I will do that part. So instead of taking ds from this, I will differentiate directly the second one. Okay, I will differentiate directly the second one, easily will get. Now from the second thing, dx is given by 1 upon a to the power 1 by n is constant, and by using x raised to n formula, it can be written as 1 upon n into t raised to 1 upon n minus 1 dt. Now the right side term you are getting in terms of t only, so that's why that dx I will replace as 1 upon a raised to 1 upon n into n t raised to 1 upon n minus 1 dt. Okay, now this definition I will delete. Now further, from this integral, constant term I will write outside. So n into a to the power 1 by n, that I will write outside. Integral from 0 to infinity e raised to minus t into t raised to 1 upon n minus 1 into dt. Now once again I paste the same integral, you can compare with the definition of gamma. So for definition of gamma, what I required kernel. So the kernel is nothing but e to the power minus parameter, and that term you are having. Okay, now if you are getting a kernel and limits from 0 to infinity, what is the evaluation of integral in terms of gamma? First, outside constant I will write as it is, n into a raised to 1 upon n. So what is the evaluation of the integral? This one. You can compare this definition with, what is the answer? So that's why this integral defines gamma of 1 by n. So that is your final answer. So particular values are given, further you can simplify it. So thus the integral I is given by 1 upon n into a raised to 1 by n into gamma of 1 by n. So that you may consider as the final answer. Okay. Now I will take a particular example. Suppose I will take a particular example. Suppose the second example. Second one, evaluate the integral. Evaluate the integral, limits are from 0 to infinity, x raised to 4, sorry, e to the power, I have to write e to the power minus x raised to 4 dx. Now first step, call that integral as a I. First step, call that integral as a I. So let I is equal to integral from 0 to infinity. I is equal to integral from 0 to infinity e to the power minus x raised to 4 dx. What is your substitution? Yes. What is the substitution? Kernel you have to compare. What is your substitution? E to the power minus t I required. Means what is your substitution? Yeah. Or we can say x raised to 4 is equal to t. And the same thing you can write, or x is equal to t raised to 1 by 4. Now differentiate this, you will get dx is equal to 1 by 4 into t raised to 1 by 4 minus 1 dt by using x raised to n formula. So further, given limits for x is 0 and infinity. Now obtain t. So for that you can use this one. If x is 0, what is t? X is 0, what is t? 0 na, 0 raised to 4 is again 0. If x is infinity, what is t? Infinity raised to 4th power, again it becomes infinity. So it becomes again infinity. So the new limits are from 0 to infinity. That's why this integral becomes, new limits are also from 0 to infinity. Now it will becomes e raised to minus t into dx is given by 1 by 4 t raised to 1 by 4 minus 1. You can simplify that also. So further, suppose I will take 1 by 4 as outside, it becomes 0 to infinity e to the power minus t raised to 1 by 4 minus 1 dt. Now again here you can notice, so that integral you are getting to the form e raised to minus t, that is a parameter, t raised to n minus 1. So it defines gamma of, what is the number? It defines gamma of, unmute and tell na, 1 by 4, outside 1 by 4 as it is, and it's defined gamma of 1 by 4. Now the question is, can I apply the property to simplify that gamma n plus 1 as a n gamma n? Question mark is there. Someone should comment on this. Okay, suppose if you are applying that property, what will be the simplification? Gamma of 1 by 4. If you reduce that number by 1, what is the answer? If you reduce that number by 1, what is the answer? Wazabaki, at least. Means what you are getting? Gamma of negative. If you are getting gamma of negative number, then don't simplify that. Okay, don't do this. Don't do this. So you keep that answer in terms of gamma only. You keep that answer in terms of gamma only. So that's why this simplification is not possible. That's why the final answer is, thus I is equal to 1 by 4 into gamma of 1 by 4. So that is the final answer, and you have to keep as it is, that no simplification for that. Okay, one example I will write, and meanwhile I will take attendance and try to tell the answer for that. Suppose a third example. Now you have to complete. Solve the integral by using gamma function. Limits of the integral from 0 to infinity, e to the power minus h square x square dx. Now what is your substitution in this example? That I will write. Suppose if you want that procedure, then put h square x square is equal to t, or x is equal to t raised to 1 by 2 divided by h, any one. Okay, so by using this substitution further you can simplify. Now I will take attendance. So I given a time to complete this. Okay, Yogesh, 1 upon 2h into gamma 1 by 2, and by using property you can write that gamma 1 by 2 as a root pi. So here that answer is I is equal to 1 upon 2h into pi. Since you can use this property, I think you are getting gamma of 1 by 2, and gamma of 1 by 2 is root pi. So that is the final answer. Okay, thank you. Today I will stop here. So next week we will continue with the further.